Hello everyone, Ken here, back with part 4 of the Data Science Project from Scratch series. In this video, I'm going to be doing some exploratory data analysis, otherwise known as EDA, of the data that we collected from glassdoor.com in part 2 and cleaned in part 3. I'm really excited about this EDA portion of the project because it's the first place where we can actually get some cool insights from the data that we collected. If you enjoy this content, please hit that like button for the YouTube algorithm. And remember to subscribe and turn on notifications to be alerted when I post the next segment of this project. Okay, so let's get started with this EDA here. So as you recall, we want to go and pull down our Git repo. So we're going to change to the folder. And then we're going to git pull. And it looks like we're up to date. I'll probably blur out my IP address there just in case. Next, we want to git checkout B, and we're going to create a new branch for this project. So this is going to be data EDA. Great. And so now we're actually using this branch, and everything that we push back up will go specifically to this branch. We don't have to worry about messing up the master. So our last two segments we did in Spider. And I think that when you're writing code and running it that way, it makes the most sense. But for the actual EDA, we're using a lot of visuals and you want to tell a story, it might make more sense to use a Jupyter notebook. So why don't I open up one of those and we'll get started. Okay. And so you can just open the prompt and write it that way. And Jupyter runs in the browser, which is really nice. So we're going to go to our documents. We're going to find this folder here, and then we're going to do a new Python 3 notebook. And so again, as you can see, this runs in the browser. As usual, we want to import pandas as PD, and we want to import, for this, we're going to be doing a lot of visuals. So matplotlib.py plot as plt, and then let's also do Seaborn as SNS. So Seaborn's also a plotting library built on top of matplotlib. And let's also read in our data. So our data frame is going to equal to pd.read csv. And I can't remember what it's called. So let's just go to the File Explorer, salary data cleaned. So I just rename it and copy it. That's the fastest way to do it for me. Perfect. So let's do head. So unless you're using like Jupyter Lab, you usually don't see, like the pop-out kind of Excel formatted folder. So we're gonna have to use a couple different commands to actually view our data. So with dfhead, we can kind of see what our data still looks like, and if we want to get all of the columns, we can just do df.columns. Perfect. So, one thing that I noticed when I was actually editing the last video is I left out a couple of things that I wanted to include, and there were a couple more things that I needed to engineer a little bit to make sure it worked in our EDA and our model. So why don't we go and clean those up? Part of exploratory data analysis is also feature engineering, and that also again falls in between maybe data cleaning and EDA. So we'll do a little bit of that to start that off. I've written some functions beforehand to save us a little time on this because I obviously made that whole video last time about what that process is like. So let me pull up that file if I can find it. Let's see here. Okay, so here is some of the code. So what I did is, as you recall, our titles had a lot of different characters, they had a lot of different formatting. Some was data scientist, some were data scientist positions, some were machine learning engineers, analysts, but we don't need all of the specifics, we just want kind of the broader category that they fall into. So I made some tags that will make them really only fall into 4 or 5 different categories. There's also seniority attached to a lot of these positions, and we want to be able to parse that out. So we basically run that, and now we can actually start formatting this ourselves. All right, so let's quickly make these work. So for our data frame, we're going to do a job simplified column. We'll just call it simple. and this is equal to data frame. Let's go back to here. So our job title dot apply, and instead of doing a lambda function, we can actually pass in this function that I wrote right here. So we can just call it title simplifier, and then let's actually look at what those look like. So df.job simp dot value counts. If you remember value counts from our last video, I really love that. So we see that there's a lot of data scientist positions, there's a lot of NAs. I saw a lot of like research scientist positions and things like that, so that might be where all of those are coming from. But to have like it not being a true data science position in the data, we can still use that as a data point. So I also want to parse out seniority from that same thing. So what we're going to do is just copy that, and then we're going to call this seniority. And then we're going to do that, and then we're going to apply seniority here. And same thing, let's actually just do it here. So you can see we have a lot of like not specified, a lot of senior, and a lot of junior. So that's a good way to evaluate that here. I also saw that we had Los Angeles in the data frame as a state, and we probably shouldn't have that. So let's actually look at that. So we're going to do df job state.value counts. And let's, as you can see, we have Los Angeles down there. So let's fix this really quick. So we're just going to do df job state equals df.job state dot apply lambda x, and then we're going to turn x dot strip. So strip just removes any extra spaces. If x dot strip dot lower is not equal to Los Angeles, else we're going to return CA. Okay, so let's see if this one works. We're going to run this again. Job state equals, oh, I have a space, so this should work now. Okay, there we go. So I accidentally created a new column in our data frame called job space state. So we're going to do df.drop job state in place equals true, axis equals 1. All right, so what that did is I just dropped that fake row, fake column that we made. In place true means we did it in the data frame, so it's saved in the data frame, and axis equal 1 is to let it know that it's in columns. Next, we want to do find the job description length. So this should be pretty quick as well. So let's see here. So we're going to do data frame description length, and that's going to equal to data frame job description dot apply lambda x, and we're going to turn just the length of x. So that's pretty straightforward. And then let's also, just to show you what this looks like, return that as well. So as you can see, the length is in words, I think. So it seems to make sense that there's that many in. It might be characters. I can't remember, but regardless, it might be interesting to know if companies have longer descriptions, if they're posting higher or lower salaries. You might want to explain away a low salary by having a really in-depth description. I don't know. I just think that could be pretty interesting. We also have competitors that are listed in kind of this, what is this? This column here. So I'm a pretty bad speller, so I'm going to just copy it. So df, and let's just see what that looks like. So it looks like they're separated by a comma, and it's -1 if they don't have any competitors listed. we're going to set that equal to df competitors dot apply lambda x, and we're going to return x dot split, and we're going to do that on, we're going to return the length of x dot split, and we're going to split on a comma. So if you recall, split makes it into a list with however many units in the list for each of our split criteria. So if there's like 4 commas, there'll be like 4 or 5 splits in the list. If x not equal to -1, else 0. So let's see how that turned out. Need that there. And then let's actually look what. Okay, so I accidentally made this the same data frame. We do not want to do that. We want the number of competitors. So let's just re-import our data. We probably want to redo that. What's wrong there? Ah. Okay, that looks good. Fix our job description, and then we're gonna change this to num comp rather than overwriting this. So now we should be able to see .num comp, and we have our numbers, and if we just do normal competition, we should still see that. Okay, perfect. Okay, next we're going to make our hourly wage into an annual wage. So I'd mentioned that we wanted to do that, and I forgot to do it in the last video. So to do that, basically you can take an hourly wage and multiply it by 2,000, and that roughly equates to the annual wage. So let's, and in this case, we actually don't need to get the hundreds of thousands or like the actual number. We're doing that actual number divided by 100. So we can just multiply the average salaries per hour by 2, and we should be able to get approximately what that would be for the annual wages in our data set. That might be a little bit confusing. If that is, just leave it in the comment section and I'll try and explain it a little bit better there. So df min salary is equal to df.apply lambda x. And so again, we're not just applying it to min salary because we actually want to use 2 columns for this. We want to use if they are hourly or not, hourly, and also the min salary. So we're going to do x x times 2 if x dot hourly, we'll do x dot min salary times 2 if x dot hourly equals 1, else x dot min salary. And I think that should work. We got some errors. I have to do axis equals 1. I always forget this. You've seen me forget it like 4 times in the series of 2 videos. So let's just check out what that looks like. That probably wouldn't help that much, but let's just look at the data frame then. So we know we did something if the min salary is greater than the max salary, or really close for a lot of these hourly people. So let's find, so we're just going to print those 3 columns. I forgot comma. And then maybe let's do can I sort these? No, I cannot. Hourly equal to 1. Okay, there we go. So as you can see, our min salary is higher than our max salary in a lot of places here. So that is kind of what we wanted to see. Now let's go in and find this max salary. So we do basically the exact same thing, and instead of min salary, we just do max here. And then max. And then let's see if this looks better. There we go. That still. I think I did something wrong. Min, max. Oh, okay, it's because I multiplied min salary again. So let's go back and just replace, let's go back and just run this again. I know it's a pain in the butt, but this is kind of part of the whole process here. So okay, so now this should work. Perfect. What we see is exactly what we want to see. So the final thing, I think, is we want to remove this new line character from the job title. So let's see if I can explain what that looks like. So we have the columns. So if we look at our company text, there's this new line character. And this is something that's really easy to just remove. So we just do df company text equals df company text dot apply lambda x dot place and with an empty thing there. And then we can see here that should be gone. All right, great stuff. Okay, so let's actually start diving into some of the data here. So the first thing I almost always do is df.describe. And this gives you, for all of the continuous variables in your data frame, like the number, it should be 742 for everything. The mean of all of the features, standard deviation, min, and the quartiles. This is good just to kind of get a feeling for what the data looks like. You know, pretty big standard deviation for founded, obviously, which, you know, just based on the way we structure that. But, you know, for what was the feature we created for that, which was age, right? You know, it's a lot smaller because it's a different metric that we're using here. The next thing I like to do is I generally create histograms for most of the relevant features. So let's just look at our columns again. And you guys will notice that when I go through this, especially in the Jupyter Notebook, it's very iterative. I, you know, keep checking further up. I keep making small changes. Again, I don't think that this is good, you know, practicing like best practices for programming, but this is generally how a lot of data science is. When you go and actually present this to someone, you clean it up. But, you know, again, Jupyter Notebooks are the best way to actually see this and see how you walk through each steps. You can also add in not just comments, but like text cells. So you can actually tell your story as you're going along. And if you go on Kaggle, you'll see that's how a lot of people really do it. So let's look at our ratings, for example. So df.ratings. And the nice thing about pandas is that there is some visualization capabilities built in, which I really like and I use for very basic stuff. So we can just do dfratings.hist. Oh, it's capital rating, sorry guys. That's rating. There we go. And so we can see that it's pretty close to a normal distribution. Let's also look at df.average salary .hist. And you can go through a loop and find all of the numerics and do this, but you know, for me, since technically like ones and zeros are still numerics, it's kind of a pain in the butt to actually do that here. So let's also do like a histogram of age. And so if you can see here, you know, age is almost never really normally distributed. It follows an exponential distribution. So if we're going to use this in our data, we might have to normalize it, especially if we're using a regression. We also built this job description length. So let's actually go through and look at the distribution there. So df.esc len.hist. Come on, baby. Great. So this also follows pretty close to a normal distribution. You can also do box plots. I don't remember how to do that. Yeah, so we should be able to follow the same format if we wanted to see that. Box plots are also extremely useful. So let's do average salary. No attribute box plot. Well, let's just do it this way. df. Oops. Box plot. We'll use the same type of system they did here. Column equals age, average salary, description length, and then what was the other one we did? Rating. And I think we can put those in brackets. Oops. I don't know why I didn't like that bracketed and. There we go. Okay, so you can see the box plots. They're obviously not normalized, so I probably should have done that first or done them individually. It really makes no sense to keep description length in here. So let's just see what it looks like without that. Cool. So we get a little bit more interesting information. So we can see that there are some high outliers on average salary. Same with there's some really old companies. Let's just look at rating. Oops, what's that? Okay. I don't think you need that if we're doing it this way. We'll see. Come on. There we go. And so you can see that there are some really low ones. Obviously, we've kept that -1 in there for ones that don't have a rating, so those will come out on the low end. The next thing we generally want to do is look at, you know, the correlations between our continuous variables. I'm going to do the continuous stuff first, and then I'll kind of go through the categorical stuff, and then we'll make some pivot tables. So let's look at the a couple different correlations. So we're going to do df, and then let's look at just the ones that we had up here. So We're going to take these. And then we're going to add, and then we're going to do .core. Oh, sorry. That is not how core works. How do I make a correlation? Core plot in Seaborn. Looks like I've used this one before. Oh, I need the parentheses. That's where I messed up. I thought that was right. Okay, cool. So you can see the actual correlations between each of these. So rating is relatively very small negative correlation with description length. Older companies generally have, looks like longer description lengths, but usually we want to make this slightly visually more appealing. So let's actually kind of plot this using Seaborn. Again, this is how I usually just plot things, as I find some of the, a place online that has it, and then I go through and build it. So we're going to use this heat map, and our core here is going to be this. We could save it into a variable, but I don't think that's practical. We don't need a mask. I don't think we need CMap. Let's just see how that looks. Okay, so that's pretty ugly. Let's actually just use some of the formatting that they use here. So I believe this controls the coloring. So let's include this back in. Just above this. And then we're going to add in an argument CMap equals CMap. And then I have to add a comma. Sick. All right. So that looks a little bit more pretty. I mean, the colors are inverted from probably what we'd want, but it looks like the strongest correlation is between age and description length, and between salary and description length. So those are positively correlated. So, that's something we could take into consideration. It looks like rating isn't really highly correlated with anything, but it's slightly negatively correlated with this description length here. So we have a core plot that we can actually use. So when we're actually model building, we do want to pay attention to what's correlated with what, and we want to avoid multicollinearity in our models. So this is something that, if we're using regression, we really want to pay attention to. Now let's actually just go into the categorical variables. So the columns, let's find ones that are categorical, but we want to, that aren't too big because we want to graph them. So, company name, we probably don't want to use that. Location is probably should fall into that. So let's do, location, headquarters, size. I think founded is the year, right? So we know we want these. Really type of ownership, industry, sector, revenue is in groups. I don't think we want competitors. Oh, actually, we can add competition in here if we want. So let's put, what was it? It was num comp. Let's see what that looks like. So it looks like age, like older companies have more competition, which is interesting and somewhat intuitive. Also, the description length is generally longer for companies that have more competition. So that's interesting. Maybe they have to explain why they differentiate a little bit more. We can go into the whys later, but it's kind of fun to think and brainstorm about what could make some of these things happen. So revenue, maybe company name. We'll just do it for gigs. We want job state. Same state. We don't want age, but we do want that. What else might we want? We don't want any of the salary numeric. We want all of these. And then that should be good. All right, so what we did here is we just are making taking all of the categorical data here. So we can maybe loop through and graph a bunch of this stuff. Let's just use simple bar charts. That's probably the best approach. So we're going to do for I in df cat.columns. And we're just going to make a simple bar chart for each one. We're going to do SNS dot, I wish there was some code help. Okay. Come on, baby. So this is what it would look like, SNS, bar plot, x is equal to, so on the x-axis we want our index. So we're going to do df cat I dot value counts dot index. Actually, let's make a new variable so we don't have to make this code super ugly. So all right, so we're going to do cat num dot index, and then y is going to be equal to cat num. So that's actually like the series. Let's see if, and then we're going to do PLT show. Let's see if that actually works. Name tips. Oh. Shouldn't need data if we did it this way. Okay, so we get a lot of really ugly graphs. But let's try and clean these up a little bit. You know, there's a lot of graphs. I just wanted to make them pretty quickly. But let's first say what each thing is. So we're going to print graph for percent %s, and then we're going to do percent. So this is some like string formatting in Python. I, and then we also want colon samples total equals %b. And then so we're going to do I, and then we also want cat num. I think we can do len. Num. All right, let's try that again. Okay, graph for location. So there's total 200 different locations, 198 different headquarters. Let's also try and make the labels like go horizontal, right? So Seaborn X label rotation. All right, looks like I've actually done this before. So here we go. For this, we're gonna just put that in there. We're gonna call this chart. And we want them 90 degrees, I think. So let's try that one more time. See if they look a little better. I mean, that one doesn't, but a lot of these really do. So let's go through and actually kind of analyze some of these things. Let's skip like locations and headquarters. I would imagine that San Francisco is probably the most popular there. So we have most companies are in this 1,000 to 5,000 range, which isn't the biggest. I think that there's 5,000 to 10,000, 10,000 plus, and there's some very small ones. We have type of ownership. So private companies are the most common in these, asking for these positions, which is a little bit surprising to me. You have some nonprofits, and we'll go through and compare salaries across all of these things as well. Industry is pretty dense, but sector is interesting. So you have IT, biotech, pharmaceuticals. I mean, I knew data science is pretty big in that field, but I didn't realize it was this big. Business services, I don't really know what that means. We have insurance, healthcare, and then we have some in agriculture, and then some that are unmarked. So some pretty cool stuff, just from like a very simple loop that's giving a lot of bar charts. So again, we can see that revenue, some of the biggest companies have, by revenue, are hiring data scientists. Also, there are some that have less than $1 million in revenue. So I guess it's probably not surprising that the biggest companies are hiring the most data scientists in terms of revenue, because I think data science is a huge driver of growth. So this is like positions by company, and we can break out some of these in a little bit more detail. So let's actually just copy this code and maybe just look at some of those really long ones more carefully. So let's do, we'll just do location. We'll do headquarters. We'll do company text. We'll do, I forgot to look at job state. That's probably a pretty interesting one. There we go. So California, Massachusetts, New York, Virginia, Illinois. What was another long one? I think that should be good, but instead of taking, all of the companies like we were doing before, I mean, where there's so many and you can't really see it, we're gonna just take the maybe the top 20. I think that'll work. See if it does. Okay, cool, nice. So location: New York, California. Looks like Massachusetts. Oh, sorry, I did this backwards. This should go after the value counts. There we go. So New York, there's a lot of job postings from there. Same with San Francisco, Cambridge, and Chicago. Headquarters, a lot of them are New York and San Francisco. No surprise there, but Chicago, big city, but that's a little bit surprising. Considering we saw a lot of Massachusetts stuff, I'm surprised Boston's kind of lower. I guess that there's multiple Massachusetts things on here, so that could be an interesting thing here. Looks like Mass Mutual is hiring a lot. Takeda Pharmaceuticals. I don't see anything. There's no Amazon. There's no, super big companies on here, which is fairly interesting as well. Okay, now let's start actually doing some pivot tables and looking at salary by some different categories here. So let's do df.columns again, just to see what we're working with. And let's do our first pivot table on index is equal to, let's do the job title like simplified that we did. And then we're also going to make the values equal to average salary. Okay. And so we get some interesting stuff. So we see analysts making less, data engineers are making slightly more, data scientists are doing pretty well. The one thing that kind of strikes me is that kind of managers are getting paid less than data scientists or data engineers. And machine learning engineers, it looks like, are getting paid a little higher than data scientists. So I think that that's like a pretty cool observation as well. Now let's add one more layer. So we can make multiple variables, and we can add, this is the equivalent to like a group by. We can add in also seniority. So we can see how these positions are getting paid at junior and senior levels. So senior data analysts are making about as much as, actually more than a normal data scientist. Senior machine learning engineers are making quite a bit of money. Anyone with senior is getting a pay bonus here. As you can see, though, analysts are making less money, but you can move into an engineering role or a data scientist role from an analyst position if you kind of focus, do projects, and you learn some of the material. Now, let's also look at a couple of different things. We can look at by age of the company. Let's do by location though. That's kind of a fun one. So we can just copy this. We're not going to do actual location. We're going to do job state. Yeah. And then we want to actually sort these. And we want them sorted by average salary. And then we want to set sending equals to false. So we want this in descending order. So we see California, Illinois, DC, Massachusetts, New Jersey. New York is really far down there on the data science kind of salary pricing here, which is kind of surprising to me. Maybe they're hiring more analysts, or maybe they're they're doing something different there. Especially because the cost of living in New York is so high. So let's actually look into that. Let's do job state by like that job simplified field. So we had job simp. And let's actually not sort them. Actually, let's sort by job values, and we're going to sort them by job state. Okay. So we want to see view full list. How to display full data frame. Output, display, set options, path value. Do I have to do anything? Do I have to import anything? Let's see if this works. Just experiment a little bit. Again, this isn't my bread and butter per se. No, that didn't work. PD dot default value max displayed rows is 10. So okay, so that was the max rows is 60. So we want, I believe this is what sets it. So let's try that again. And then let's try this again. There we go, nice. So let's put this up here. And now we can see we want to go to New York. I clearly passed New York. Not great at the alphabet. Okay, so we want to actually do a count here. Equals count. So this is actually going to give us the total. So again, let's look at New York. So they have 40 data scientists, 4 engineers, and 14 analysts. Let's look at, for example, California. More analysts and engineers, I think proportionally more. And then let's look at Chicago. So Chicago is hiring a lot of directors. So, you know, that could be a factor. There's a lot more diversity here, and actually only a few analysts. So that could be what's actually bringing that average New York salary down. Let's do one more kind of exploration here, and let's just filter this data based on only data scientists to see, you know, how different that is for New York, rather than some other states. So we're going to do df.jobSimp is equal to data test, and then we're just going to keep job state and remove this. And then we also want to remove this count. So by definition, it usually uses the average. And then let's kind of sort values again by average salary. Okay. Cool. So it looks like DC is actually leading in the average salary category. New York's still behind, which I think is a pretty interesting insight. So maybe you're not getting as good bang for your buck in New York as you are in some other states. Okay, let's also look at some other things. So let's make a list here. So maybe salary by rating. Actually, I do this a lot. So we want salary x rating, salary rating, industry, sector, revenue, number of comp, hourly, employer provided, Python, R, Spark, AWS, Excel, description length, and then type of ownership. So I'll go through and make all of these pivot tables, and we'll see if we find anything interesting. Of course, like before, we should probably go and loop through. So let's do that. Rating, industry, sector, Probably should have done these better to start. Hourly. So provided. Python yn r yn. Should have made Spark and AWS and all of these yes no also, but I didn't. So Excel, we actually don't want description length here. That would be overwhelming. And then type of ownership. Nice. See what I spelled wrong. Equals df. And then so type of ownership is not in indexed. Type of OW ownership. Great. So now we have this data frame. So we're going to do for I in df pivots dot columns print. We're just going to print I, so it'll say what column it is, and then we're going to do print pd dot pivot. And that pivot table is going to take df pivots as the data, index is equal to I, values equal to average salary. Yeah, let's see how that works. Key error none, huh? Didn't like that. Okay, let's do some debugging here. So we'll just comment this out, see, make sure that works. We know that works. Problem is in the pivot table. So, you know, the index is equal to rating industry values equals average salary. So let's just print the same thing a bunch of times. So that does not work. Can we not print it? Fair enough. Oh, I'm not using a pivot table. That's what the problem is. Classic. So there's a difference between pivot and pivot table. I obviously made that error there. Table, there we go. This will fix all of our problems. df pivots, index equals I, values equals average salary. And then we cross our fingers and, oh, it doesn't like our value of average salaries. Oh, because average salary isn't in here. Duh. Come on, Ken. There we go. So rating, yeah, I forgot rating was continuous. I don't know why I actually put that in here. Industry, all right, we want to sort by values here. Great. Okay, so the companies that had no ratings. Oh, sort values. Non-typed object has no attribute sort values. Oh, because it's inside the print statement. So as you can see, this is a very iterative process, and this is why I did it this way, is so you can see the mistakes I make and see that it's natural for everyone to, have some debugging to do. So, companies that scored a perfect 5, obviously rating of -1 is they're unrated, but of perfect 5 are offering more money. Also of 2.5, which is really low. So this looks like it could be pretty random, but we're seeing more 2s at the bottom, except for this 4.81. The sample size for these is probably pretty small. Industry, it looks like retail pays a lot. We should also probably include the counts for these, just because they're so high. But motion pictures pays a lot. Let's see what's on the bottom end. We would expect nonprofit. Gambling is very low, which is interesting. Sporting goods. Let's see sector. So construction's the lowest. Nonprofit's pretty low, is what we would expect. Real estate pays reasonably well. Again, media is kind of at the top here, which I think is interesting. In terms of company revenue, so it looks like these are the top are kind of the lower revenue companies, and the ones and then also the highest, but the bottom's all these kind of like mid-tier revenue companies, which I think is interesting. So if you don't have a lot of money, or you have a lot of money, you're willing to pay. Obviously these are anecdotal observations, but I still think that that's relevant. Companies with a little competition, it looks like they pay better. I wouldn't put too much weight in this. Hourly workers obviously pay a lot worse. When the employers the salaries provided, it's higher. We're looking at Python. So Python, when it's in the description, it's higher. When R is in the description, it's lower. But the sample here is small. Remember, there's only two actual R samples there. Spark is high, AWS is high, Excel is lower. Most data scientists don't use Excel. This is probably more catered to analysts. And then if we're looking at ownership, so if you recall, higher up, the companies with the most counts, like the most job postings, were private. But it looks like public companies are in general paying the most. And universities are paying a reasonable amount, which I think is interesting. Government is, government's the government. Nonprofit, of course, is also on the lower end. We ran, it looks like, into some more errors, but we got exactly what we needed regardless, so it doesn't matter too much that we ran into some errors down there. Okay, so you can go down a pretty aggressive rabbit hole with all these pivot tables. You can also add columns to look at, like multiple things at the same time. Let's just do a quick example of that. But in general, I think I've got most of what we need from the exploratory analysis. Let's just do pd.pivot table, and let's look at what's like company revenue and if they're looking for Python jobs. So df pivots index is equal to let's do revenue, and then we're going to set our columns equals to Python yn, and then our values equals to average salary. So as you can see here, this is by payment. Let's do count. Cool. So we can see that by each range who's really looking for more Python people in general, which I think is pretty cool. Yeah, so as you can see, we can look at the different companies and compare who's hiring maybe either the most data scientists or the most data scientists who are interested, who have Python. And if we wanted to, we could make a ratio, but from this 1 to 2 billion, it looks like they're really focusing on Python in comparison to that over 10 billion maybe, where you're looking at actually less focused on Python and more focused on other skills. Okay, so the last thing I thought it would be fun to do is to maybe make a word cloud with the job descriptions to see what actual, words are most popularly used when talking about candidates. So I'm actually going to go in and pull up some of my old code. All right, so let's actually pull up this code, and you can see it here, and we're just going to copy in some of the code that we used to be able to get this going. So I didn't have to use Twitter Scraper, I don't have to use datetime, I already have pandas, so I probably need this word cloud, and then I probably also need those. So let's get word cloud here, we'll import that, and then we might need these NLTK toolkits as well. So let's just import all those things and see if I have them. Great, I do. So it's really common to use your old code and reference it. I do this quite frequently. So I think we just want the words, and we want to get rid of a lot of no, we don't want to get rid of too many duplicates in this one. So let's take that. That looks pretty good. We want to get rid of stop words, so we're going to include that as well. I haven't done this one in a while, so we don't have any unwanted words. We want to actually get text here. And obviously we're going to be versioning this for this actual use case. And then we don't have a mask. We have this word cloud that we want to generate. And then we want to show it off. There we go. All right, so let's see if we can work through this and actually make it work for us here. So I don't think there are any duplicate jobs, and so we can just use data frame job description, and that should work. Now should filter everything out. We take the text and we join everything to make it into one just really fat word chunk. So we don't have a mask. We do have to remove stop words. So let's look in here and see how I did that. Okay, so it looks like I didn't have to define that. That's already defined. Those things all look good. We don't need to recolor it. So we should just be able to do that. And then let's see how it looks. Let's see if we did that really fast. So text. Oh, I don't have unwanted. So in words filtered. So I can just do that. And again, it didn't work when we crossed our fingers last time, but I'm a bit more optimistic this time. So word clouds can take a little bit of time to generate. I just think that this is like a nice way to understand the data. You know, I use word clouds a lot. They're not particularly useful other than that, but again, this is a pretty interesting use case here. So it looks like we're missing something. White, max words height, generate text, image show. Let us see. Oh, we have to pass our actual word cloud in here. That seems to make good sense. So let's give that a go. This is probably going to be the last thing we do in the exploratory analysis. I think that this is so deep and there's so much information here. I'll probably do a separate video where I talk about my findings from this. I think that just the descriptive analysis, the EDA, could be even its own project here. But we wanted to make sure that we actually are going to build this model. So let's kind of focus on doing that in part 5. Okay, cool. So we have this neat word cloud. You see data a lot. You see team, solution, product, client, business, obviously machine learning, research, financial data analysis. And again, a lot of really cool stuff here. Before we log off, let's remember to just push this to our GitHub repo. We're going to name this data cleaning. And then we're going to go in here, we're going to git add, we're going to git commit -m added data cleaning Jupyter Notebook, git push. So we have to set it because git push set cool. So this is being pushed to our GitHub. We will be able to see it here when we reload it. And we can go into data EDA that exists. Now we want to create a new pull request. And then, so EDA analysis, we're going to create the pull requests. And then we are going to so I'm in a different account. So am I in a different account? Oh, I'm in my work account, so I can't merge this. I'll go into my playing numbers account. To actually merge that pull request. So let's go data salary proj, pull requests, and then here we go. We can go in and merge this, confirm merge. So that is back up to date. Again, in part 5, we're going to go through the actual model building process. We'll try a couple different models and see what performs the best for predicting these outcomes. As usual, thank you so much for watching, and until next time, good luck on your data science journey.